Let's start with the type stuff, and then I'm gonna review proof of stake. It's gonna take a lot longer than I thought to do all of the articles, because yesterday I reached the rate limits for 1 hour, so I had to stop. And so far, I think I did only 4 or 5 categories or main categories. I did this one, 1, 2, 3. This one I'm halfway through it, and 4 is the so I did 4 in total, I think, and I still have a bunch of more to do. So until I haven't finished all of them, I'm gonna stream less because I wanna do all of them off stream. And then once it gets time to review all of them, then I think I'm gonna stream more to get more articles done each day.
Fa,
Fa,
Does.
fisso,
fisso,
Set. Unchanging.
3,
3,
3.
desiderare,
desiderare,
Desire.
aria,
aria,
Air.
bene,
bene,
Well.
anche,
anche,
Also.
giocare,
giocare,
Play.
piccolo,
piccolo,
Small.
fine,
fine,
End.
mettere,
mettere,
Put.
casa,
casa,
Home.
leggere,
leggere,
Read.
mano,
mano,
Hand.
portare,
portare,
Carry.
grande,
grande,
Large.
compitare,
compitare,
Spell. Words.
aggiungere,
aggiungere,
Add.
anche,
anche,
Even. Also.
terra,
terra,
Land.
qui,
qui,
Here.
devo,
devo,
I must.
grande,
grande,
Big.
alto,
alto,
High. Tall.
tale,
tale,
Such.
seguire,
seguire,
Follow.
atto,
atto,
Enact.
perché,
perché,
Why.
chiedere,
chiedere,
Ask.
maschi,
maschi,
Men.
cambiamento,
cambiamento,
A change.
è andato,
è andato,
He. She went.
luce,
luce,
Light.
tipo,
tipo,
Kind. Of thing.
spento,
spento,
Turned off.
bisogno,
bisogno,
Need.
casa,
casa,
House.
immagine,
immagina,
Image.
provare,
provare,
Try.
noi,
noi,
Us.
di nuovo,
di nuovo,
Again.
animale,
animale,
Animal.
punto,
punto,
Point.
madre,
madre,
Mother.
mondo,
mondo,
World.
vicino,
vicino,
Near.
costruire,
costruire,
Build.
se stesso,
se stesso,
Himself.
terra,
terra,
Earth.
padre,
padre.
Father.
And they changed this thing again. I don't know. I don't remember really well exactly how proof of work works, but I remember, obviously, I studied a lot of that already. So I remember some of the things, and I'm pretty sure that I'm going to remember very fast once I start searching for it. But the nuances I don't remember really well. So I think minors compete for solving the puzzle. It's a mathematical puzzle, and then the ones that get rewarded first gets the money in return. And they validate the blocks, and the puzzle is there's something to do with the hash functions of that connect each block to each other. The nonce of the block and something else, and then you put all of the stuff in the hash to verify the transactions are valid in relationship to the history of the network. And then based on that, you have the puzzle, the mathematical puzzle, and then you use either CPU or GPU to solve the puzzle as fast as possible. And there's some element of luck as well that I don't remember really well. I want to see if I can find information about the specifics of the blocks that it uses and the equation. Maybe I should look into the Bitcoin source code.
Proof of work. How, what is it, and how does it work? Proof of
I think each one is going to be different, I think, proof of work, depending on the chain. So I have to give a more generalized thing here, but I think I can put a section about Bitcoin.
Proof of work, POW, is a central part of cryptocurrency and blockchain technology. But what is proof of work, POW, and why is it so important to cryptocurrency? What is proof of work? Proof of work, POW, is a protocol designed to make digital transactions secure without having to rely on a third party. Essentially, POW requires members. Background. The concept behind proof of work, POW, was originally invented by Cynthia Dwork and Moni Nair. More specifically, proof of work, POW, is a piece of data that is hard and costly to produce, but easy to verify once it's been generated. Many times, people explain this data as the solution to a puzzle. Essentially, members of a given community work to solve a complex puzzle. This is the work in proof of work, POW. In order to create the data or solve the puzzle, a miner must compute through a very complex equation. Because each attempt at the equation builds on previous solutions, any new solution essentially verifies previous work. At the same time, the work required to solve the equation generates a new piece of data. This is then added to the growing chain of data. From there, the process basically starts over again. Advantages. There are a number of key advantages to using proof of work, POW. Because it's very hard to do the work, POW reduces the risk of a 51% attack. At the same time, each solution is easy for the community to verify. This makes it easy to check all transactions for trustworthiness. It doesn't rely on a single third-party transactor. This builds a trustless and transparent network. POW also sets a limit on how many new blocks of data can be generated. For example, miners can only create a Bitcoin, BTC, block every 10 minutes. Disadvantages. POW is expensive, labor-intense, and uses a lot of energy. Creating a new block requires a lot of energy, which a recent study.
One question I have in my mind is if all the cryptographic functions are NP hard or I think that not all of them are NP complete, but the ones that are relevant are, I think. Because you want to be at the boundary of what's irreversible computationally to create secrets. I think that's the key. I also wonder if there's a relationship between that and the speed of light, because it's very similar, the concept of not being able to go faster than light and not being able to reverse in polynomial time. I think it's probably related somehow.
Proof of work. How? Last edited at Wakaro, September 20. The Ethereum network began by using a consensus mechanism that involved proof of work. How? This allowed the nodes of the Ethereum network to agree on the state of all information recorded on the Ethereum block. Proof of work in mining. Proof of work is the underlying algorithm that sets the difficulty and rules for the work miners do on proof of work blockchains. Mining is the work itself. It's the act of adding valid blocks to the chain. This is important because the chain's length helps.
So let me, I think I'm gonna change this description here. To provide a way for different agents to interact in system, preventing spam. Yeah, this I already did, so I'm gonna do the other one. I think I'm gonna redo this one, and instead of putting this stuff here of the benefits and the applications, I'm gonna put the different, how it works on different, how it worked in Ethereum and how it works in Bitcoin, I think. Then I might try to find the source code as well. If it's too hard, then I'll leave it like this, but if I can find the source code for either Ethereum or Bitcoin for the proof of work mechanism, I'm gonna put that source code here. It's probably, Ethereum is probably in Go, but Bitcoin I have no idea. Probably in C++ or something like that. Not sure. I wonder whether or not I should talk about mining pools. Maybe that's a good idea. I think I'm gonna talk about it, so do another category after this, shoe mining pools. Or maybe I should do, because there isn't much to talk about, so I'm not sure if it's worth. But maybe I'll do a small one. I'm not sure if that's the best way to put it. Trying to think about. I think I'm gonna write first, and then I think about how I would say how I can improve later. And now I have to think about whether or not I'm gonna get into game theory, but I think I'm gonna do. I'm gonna say some stuff about this. Because it might be worth to put these things separately in different articles, but I think I'm gonna end up doing that anyway. Like I'm just put something smaller here and then I do a bigger version later where I talk more about this stuff and I do more research about it. Outside of these money pools is that they allow for more people to get into the game because it allows them to make money even though they might not have a very strong GPU, CPU. There's only return on investment if you can implement several GPUs to compete with other players. The positive side of this mining pools is that they allow for more people to get into the game because it allows them to make money even though they might not have a very strong GPU, CPU. Usually there is only a return on investment if you can implement several GPUs to compete with other players for rewards. Downside of this is that it leads to more centralization because the game theory of market dynamics is going to most likely converge things into operative distribution over time, which means very few players will have most of the power. Means some pools will have more control over the blockchain because they are the ones mining all the blocks. The other problem with this is that from a macro perspective, because it becomes profitable to buy GPUs, CPUs to invest, a lot of people start doing that, which makes the overall GPU, CPU market to become very unbalanced and starts damaging other industries as well. A potential problem is with the environment, but that is a far more nuanced one. For more nuanced discussion, maybe. And but that is a far more nuanced discussion. It's hard to tell if it is really a problem or not. Because of all the politics involved. I think I'll leave it like this for now. Like, there's obviously a lot more stuff to talk about, but I don't wanna, because then it's gonna take away from this article and what it's supposed to be. But I think I'm gonna be focused more on blockchain, to be honest. And the problem is that it's gonna take a long time to finish all of the articles that I have to do, the algorithm ones. And my concern is that I start going too fast through them and not caring too much about the quality because I want to get to the blockchain stuff as fast as possible. Maybe the best thing to do is to go back and forth between them. Like do one category for the algorithms and then go back to more blockchain focused stuff after I finish writing or using ChatGPT to write all the articles, obviously. And also, I've seen that it looks like they are going to change their plan, and they're gonna allow people. They're gonna maintain a free version, which is very good news. And they're gonna charge only 20, I think, instead of 42 for the pro version, which is also good if it is true or not. I've seen on Twitter, and I think it was some person that works there that I don't know who it is, but so I don't know when this is going to be implemented or not. And it's also possible that they might change their minds at some point and then start with the paid version only. So because I don't know, I think it's better to write all these articles. I think after I write all these articles about the algorithms, then I'm probably not gonna use GPT much to write the articles. I'm gonna use it more for research, I think. So it shouldn't, after that point, it shouldn't change much for me if they start. It's obviously gonna change because it's a very good tool, but it's less bad, I think, because for the algorithms one is really, really good because I don't wanna research a bunch of about these problems here that I don't really care about, like all this and Queen's problem and all this stuff. It's much better to have ChatGPT write everything and then I just reveal whether or not it's correct. Not sure if this is the right way to write it. Yeah, I suspected that. Yeah, and I think that's based on these answers here, the quality is not good of ChatGPT for the articles. I think it is good enough if you don't know the topic, so just to cover more surface area, let's say, about a niche, but I think that the ones that are gonna be that are better to write is the ones that you do it yourself without any input from ChatGPT. At least for now. Maybe 6 months from now it's gonna be different, but yeah. Blah blah blah. It doesn't matter. So I think now I'm gonna search for how it works on Ethereum and then in Bitcoin as well.
This is important because the chain's length helps the network follow the correct fork of the blockchain. The more work done, the longer the chain, and the higher the block. Ethereum transactions are processed into blocks. In the now deprecated proof of work Ethereum, each block contained block difficulty, for example, 3,324,092.
Actually, I was gonna write here, I think, as well. Maybe I'll write after this stuff. This I have to search more, I think. I know how it works, but it's hard to explain. Because I don't have a very good understanding of the nuances of the algorithms. I know there is a hash function that points where if you have the initial string you can solve, and then to reverse is almost impossible because it's in PR. So if you have only the public key, you can't find the private key because you can't use the algorithm for that. It's irreversible. But with the private key, you can find the public key because it's deterministic and is easy to solve. But this process, because that's the thing, I wanna explaining how it works, but I know that obviously it's gonna be different because the actual puzzle for solving the block is gonna be a different thing, and that's the thing that I don't know the nuance about. So maybe I'll leave this for after I do. I'll go back after I do this. So explain first because I'll research and find out what is their algorithm, and then I'll go back and put there.
How did Ethereum's proof of work work? Ethereum transactions are processed into blocks. In the now deprecated proof of work Ethereum, each block contained block difficulty, for example, 3,324,093,263,262,715. Mix hash, for example, 0x44K81079F83B1307980724417005D9A665C5AC8BDF2F39A3CDF3B29. Nonce, for example, 0xD3EE432B4FB3D26B. This block
So I'm gonna write.
This block data was directly related to proof of work, the work in proof of work. The proof of work protocol, ETH, required miners to go through an intense race of trial and error to find the nonce for a block. Only blocks with a valid nonce could be added to the chain. When racing to create a block, a miner repeatedly put a dataset that could only be obtained by downloading and running the full chain, as a miner does, through a mathematical function. The dataset was used to generate a mix hash below a target that is dictated by the block difficulty.
Let me see if I understand. To which block of blockchain contains a block difficulty mix hash unknowns. Graph protocol. So for creating the proof of work consensus. Yeah, this is not really good, I think.
The dataset was used to generate a mix hash below a target that is dictated by the block difficulty. The best way to do this is through trial and error.
Don't understand this part really well. So the question is here, how? What steps was used to generate the mixed hash below a target that is.
The dataset was used to generate a mixed hash below a target that is dictated by the block difficulty. The best way to do this is through trial and error.
The way they do it is by putting a dataset which contains a full chain through a mathematical function that generates a mixed hash below a target that is dictated by the block difficulty.
The difficulty determined the target for the hash. The lower the target, the smaller the set of valid hashes. Once generated, this was incredibly easy for other miners and clients to verify. Even if one transaction were to change, the hash would be completely different, signaling fraud. Hashing makes fraud easy to spot. But proof of work as a process was also a big deterrent to attacking the chain. Proof of work insecurity. Miners were incentivized to do this work on the main Ethereum chain. There was little incentive for a subset of miners to start their own chain. It undermines the system. Blockchains rely on having a single state as a source of truth. The objective of proof of work was to extend the chain. The longest chain was most believable as the valid one because it had the most computational work done to generate it. Within Ethereum's POW system, it was nearly impossible to create new blocks that erase transactions, create fake ones, or maintain a second chain. That's because a malicious miner would have needed to always solve the block nonce faster than everyone else. To consistently create malicious yet valid blocks, proof of work was also responsible for issuing new currency into the system and incentivizing miners to do the work. Since the Constantinople upgrade, miners who successfully create a block were rewarded with 2 freshly minted ETH and part of the transaction fees. Omer blocks also compensated 1.75 ETH. Omer blocks were valid blocks created by a miner practically at the same time as another miner created the canonical block, which was ultimately determined by which chain was built on top of first. Omer blocks usually happened due to network latency. Finality. A transaction has finality on Ethereum when it's part of a block that can't change. Because miners worked in a decentralized way, 2 valid blocks could be mined at the same time. Pros cons. Proof of work is neutral. You don't need ETH to get started, and block rewards allow you to go from 0 ETH to a positive balance. With proof of stake you need ETH to start with. Proof of work uses up so much energy that it's bad for the environment. Proof of work is a tried and tested consensus mechanism that has kept Bitcoin and, compared to proof of stake. At a high level, proof of stake has the same end goal as proof of work, to help the decentralized network reach consensus securely. But it has some differences in process and personnel. Proof of stake switches out the importance of computational power for staked ETH. Proof of stake replaces miners with validators. Validators stake their ETH to activate the ability to create new blocks. Validators don't compete to create blocks, instead they are chosen at random by an algorithm. Finality is clearer. At certain checkpoints, if 2/3 validators agree on the state of the block, it is considered final. Validators must bet their entire stake on this, so if they try to collude down the line, they'll lose their entire stake. More on proof of stake. More of a visual learner? Further reading. Majority attack. On settlement finality. Videos. A technical explanation of proof of work protocols. Related topics. Mining. Proof of stake. Was this article helpful?
Yeah, that's what I'm curious about.
Good morning. Happy Bowtie Friday. This ETH.build is focusing on blockchain. Really cool thing. I'm wearing this clown bow tie or Bitcoin bow tie for it. Here we go. So, in the curriculum so far, we jammed through key pairs and hashes and ledgers. And what we found is if we want to transact value back and forth on a distributed network, not a centralized one, we end up having problems of coordination. We end up having this issue where we can't find a consensus between disparate parties because they all receive different transactions at different times. And there was a lot of different ways to solve this, but none of them were great until proof of work came along. And we dove into the Byzantine generals as a side quest. But what we learned there is basically the generals needed to prove they had an army when they sent messages over an insecure network. So then when they were received, the receiving party could tell that that person was indeed a general with an army that was going to attack, and then they could coordinate. So with this ledger, we we are pumping in transactions from the network, and these are just random, it's just simulated transactions. But we'd rather not Eve have to have an entire army behind her to be able to send a transaction. So we're going to abstract away the proof of work, the work that you have to do, into a block of transactions and let a miner work on that. So what we do is we bring in a block, and this is just going to hold the transactions, whatever's coming across the network. Okay, well, man. So whatever comes across the network, we're going to load up into this block. And then if we were to look at the structure of this block, it also has a nonce. Okay, and what that nonce does is it lets us tweak this hash. So what we're doing, if I were to take this entire block and
Cryptocurrency?
stringify it and hash it, I would get this hash up above. And we'll see that as transactions change, that hash changes. But also, as I type in this nonce, that string is also going to change. So I'm doing some work.
And so the thing is, this is an explanation of probably this stuff I already know, but the thing that I don't know that I'm curious about and that I haven't studied yet is the actual algorithm, how it works. So I'm gonna study this after. I think I'm probably gonna study this tomorrow once I come back to it, and then I'm gonna replace the code that I have there with this one here. And I think I'm gonna do one, put the code for each one with that explanation here, and that's gonna be the article, I think. So I do Ethereum and then Bitcoin and explain the hashing algorithms. And hopefully I can do that for all of the other ones as well. And then this, yeah, so I think I'm gonna continue tomorrow because I have a lot of articles to do yet. Like all of this stuff, and I want to finish this as fast as possible. So if I keep the pace of 4 a day, let's see. There's still 11, so hopefully 3. I want to try to finish in 2 days. So if I can do 4 more categories, which is really hard because each one of them has around 10 different articles. So it's actually 50 articles. Actually 60 articles. No, actually it's a lot more. It's 110 articles yet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 110 articles that I still have to do. And then after I finish all of them, then I'm gonna focus more on this thing here, I think. I'm gonna spend more time streaming, I think, and finishing these articles. And I think what I'm gonna do is do it like this, where I do one of the categories, review one of the categories, and then go back to proof or to blockchain stuff. I think that's better than to, otherwise I think I'm gonna start rushing too much to finish all of them because there's so many. So I think it's better to just do one category, then go back to blockchain, and then after a while go back to algorithms and go like that until I finish everything. So I'm probably gonna come back tomorrow. If not, then very high chance that I come back Sunday. So yeah.